After finding the NPV, the BCR, the NKR and IRR, we also can do the sensitivity analysis of a project on MS Excel. And we remember that there are three cases that we dealt with. One was the switching value of cost, and the other was the switching value of benefits, and the third one was the switching value of discount rates. So let's see that how we can do it on a Microsoft Excel. You remember that we had this stream of Lahore Sialkot motorway project in which we had 10 years, and definitely there is a discounting factor that we have, and we have costs. These are the costs, and this is the column of the benefits. But we have some additional columns here. This one is the new cost column. As we remember that we experimented with the changes in cost, we experimented with the cost by adding some percentage of it, and one would be a lower increase in cost, which is here, and the other one will be the higher increase in the cost, which is represented by delta CH percentage sign. So we can do this thing, and for that we are going to resort to an input cell. These green highlighted cells are basically input cells in which we will input the lower increase and then the higher increase. For example, if the lower increase is 63%, we keep a difference and we make it 68%, so that the difference is 5% and not more. Because we know in interpolation it is our convention that we keep the difference between the lower value and the higher value of the change variable is 5 at maximum, so we keep it up to that level and not more. So we use this value here that is in G1, and you can see that we have F3, which is the value of the cost, and we are adding the G1 column multiplied by the original G1 cell multiplied with the original value of the cost. It means that we are adding 63% in the column of in the cell of the cost, because F3 has cost. So it will add 63% of the original value of the cost in the original cost. So now you can see that this value has increased substantially. It was 20 and now it became 32.6, so it's a 63% increase in it. Again, 63% in 20, 63% increase in 4 will make it 6.52, because we have to add this increase in the original one. So therefore the original one is F6, and this is the percentage increase in the original, the result of which is the increase which is added in the original one. So this can be verified from the last column. It is also there, 7, and then 63% of 7 getting added into 7, which makes it 11.41. So this is the higher increase because we kept it 5% away from the lower value, and here the original cost is in F3, and this percentage of F3 getting added will give us this value, and we can verify this from here. F12 plus H1 into F12, it means that we are adding 68% of the original costs in the original cost. This will give us certain value which will be 11.76. So we have experimented with these two values, and this is the benefit column. Now we can calculate the net benefits. There are two net benefits that we are calculating here. One is the net benefit with lower increase in cost, which is this, and this is the net benefit with higher increase in the cost. In this case we will use the original benefits and the lower increase cost column. Here you can see this is the original benefit column, and this is the lower increase cost column, and its third cell in this case, where the column is valid because all of these values are based on this column and that column. So here it is 50 minus 11.41. This gives us that net benefit set in which the difference is taken between the original benefit and the lower increase possibility. Here this set of values is by the difference of the original benefits and the percentage increase in the cost, which is the higher percentage, which is 68%. So this will be the new value of the cost after 68%. The difference is taken between this and the benefits value. We can verify it from here as well. Benefits minus cost, we will get this value. So now I have these two columns, and the sum of this is 0.17 and the sum of the other higher increase in cost column is minus 3.08. So the interpolation is possible because one of the NPVs is positive and the other is negative. We can see that we can apply interpolation simply by using this formula. This is a lengthy formula. You can see it from here, from this column, from this formula bar, and this formula bar can help us to understand this interpolation formula. I have pasted this formula separately, and it says that if J13 is greater than 0 and K13 it is less than 0, then we will do this thing. It will be this. This is the formula of interpretation. But what is the purpose of using this? It says that we can see that J13, this is the cell I'm talking about. If J13, which has pKr 0.17, if it is positive, and if K13 is less than 0, that is it, if it is negative, which is here, then we can do the interpolation because they should have opposite signs. If this condition is not holding, then we cannot do the interpolation. So we started with this condition in which we are using the AND operator, which asks us to combine more than one conditions and require all of them to be true at one point in time. Here both of them should hold, that is, the first NPV should be positive and the second one should be negative. And if it is so, then we can say that we have the fulfillment of the requirement of the interpolation formula. So after fulfilling the requirement of one positive and one negative NPV, we will write the formula of interpolation, and it says that the value in G1, which is the percentage increase in the cost which is lower, added in the difference of the higher increase in the cost and the lower increase in the cost, then we multiply it with the NPV at higher lower discount change in cost, and we divide it with the sum of the NPV at lower change in the costs and the absolute value of the NPV at higher change in the costs. So this is that interpolation formula that we have been studying before. Here I have highlighted it with the help of the Excel formula, Excel equivalent of it. Now we come back to the calculations. The result of this is 63.2678%. It shows that at 63.2678% increase in costs, the NPV will turn to 0. Here we have experimented this for the sake of verification, because this is the net benefits stream at switching value of costs, and as per our information and calculation, it is that level which is written in H14 column cell, H14 getting multiplied with the benefits with the costs, that is F3, and adding it in the original level of costs. So this is the original level of cost, this is the increased value of costs equal to the switching value of costs. So this is the new a level of costs after increasing it to the switching value level, and this is the benefits column, that is ith column. Third is the cell in it. So B minus new C at switching value level will be equal to this. So we take the difference of the two and we verify it from other cells, and here we can see it is getting verified, and we see that the NPV is nearly equal to 0. Definitely it's not precisely equal to 0 because of interpolation. The answer is not precisely equal to 0. However, still we have a value very much close to 0, and it was possible by using the function in MS Excel, and a little bit of usage with caution and care can enable us to do the tedious process of finding the switching value of the costs on using on Excel with ease. Now in the next video we will learn about the switching value benefits, as well as in the video after that we will learn that how we can calculate the switching value of discount rate. Thank you.